All right, let's do some Mathity-Math. We got here our financial math section of the practice quiz. So let's just do the financial math practice quiz. Question 1, it says Harry has $75,000 to invest for 4 years. He's been given 3 options. So what we're going to do here is we're going to go through these 3 options, and we're just going to see which one makes Harry the most money. Okay, because when the question ends, it says which one would maximize his investment. All right, so here we go. First things first, this question does ask for simple interest, but looking through the IB formula booklet, simple interest is not given. So on your actual quiz, I don't think I will give you simple interest just to kind of be consistent. And so this question I would change to say that it's going to be 4.8% per year, and we'll just say compounded annually. So it says compounded annually, okay? And that'll be a little bit more representative of what you'll see on your actual quiz. So all this really comes down to is using this formula that's given to you, that your future value is your present value multiplied by 1 plus your interest rate divided by 100. And remember, that just moves us out of percentage form. Multiplied by how many times you compound a year, raised to the power of your compounding multiplied by the number of years. Okay, so that's our formula. So looking here, the present value is 75,000. You can actually probably set all of these problems up almost the same, but we'll do them one by one. So you get 75,000, okay, and then we're going to multiply that by 1 plus our rate of 4.8% divided by 100. And because we're compounding only annually or once a year, this is just multiplied by 1, so it stays the same. And then we said it's for 4 years, and again, 4 times 1, because the compounding is 1, is just 4. So that right there is it. Okay, so if we looked at this real quick, we could actually just plug this all into our calculator, or we can do it step by step. I think I'll do it both ways so you guys can see how the whole thing works. So I could say 4.8 divided by 100. That would be this part. If I was nervous, I'd hit enter. Plus 1, there you go. You could raise that to the 4th power, and then multiply all that by 75,000. That would work, right? And you're going to get 90,470. For this quiz, we're always rounding to the nearest one value, the nearest dollar or the nearest Great British Pound or something like that. So we get, this one would be 90,470. Okay, if you want to do this a little bit more efficiently in your calculator, you could say 75,000, right? Multiply by, you could do that parenthesis. And the only thing you have to do different is just parenthesize that so your calculator reads it correctly. 1 plus 4.8 divided by 100, done, done, and then raise that to the 4th power. And there you go, you get the same answer, okay? So either way you like to do that, that's fine. Fine by me. Okay, so the first one, we got 90,470. Let's do the next one. Okay, so coming down this way, we can see everything good. Okay, so here we go. Same song and dance, but now it's a 3.2 interest rate, and it's compounded quarterly, which means we're just going to multiply this by 4 and that by 4. So here we go. My initial value, my present value, 1 plus 3.2 divided by 100 times 4. I'll just write it out for you guys because that's our compounding. Quarterly means 4 times a year, right? I should write a little nicer. And then it's raised to the power of 4 years multiplied by compounding. So this is going to really be 400, and that's going to be 16. We can do that math in our head. Okay, so here we go. Same thing. Let's see. We got 75,000. Ta-da! Multiply, open my parentheses, 1 plus, oh, remember we've got to parenthesize that. We'll say open, 3.2 divided by 400, close it, and then raise to the 16th power. Dum-dum-dum. So we get 85,198, and it doesn't round because it ends in a 0. So here we go. This one is 85,198. Okay, so far, plan A is winning. Let's see if plan C can take it. Okay. Dun, 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 dun. Here we go. There we go. Okay, same idea. Principal value or present value. 1 plus this one's going to be 2.9%. divided by now is compounded monthly. That means 12 times a year. So 12 times 100 is 1200. Then you got 4 years times 12. So 4 times 12 is 48. There we go. This is our formula. So let's punch it in and see who wins. Okay, 75,000. Da da da. Move that there so now you can see what's going on. There's 75,000. Open that parenthesis. 1 plus. Open that parenthesis. 2.9 divided by 1200. Close. Close. Raised to the 48th power and 84,200, and we round up, so we say 13. There you go, and you can see right there, clear as day, the winner is Plan A. So I come down here, I ignore the fact that the question started, his name was Harry, and then ended, his name was Harvey. That's my bad. And we just write Plan A. Voila. Keep it moving to question number 2. All right, here we go, question 2. I'm going to modify this one a little bit too to be more reflective on the test. On the test, I'm not going to give you a monthly interest rate. I'm probably going to give you an annual interest rate. This is how I would say it, of 0.3%. And then I would make a note here, and it would be compounded monthly. And again, I'm just trying to make this a little bit more consistent with what you'll actually see on the quiz, because when we were going over the lessons, we really only worked within the context of the given formula, so I want the test to be within the given formula, okay? So savings account with an annual interest rate of 0.3% compounded monthly, and that'll be just fine. So he has $1,500, that's like his initial value or his present value. So he's writing an expression for his savings. Now savings is like the money he'll have after time happens. And we're going to represent that money with M. Okay, and then time is just T. So we're actually not calculating anything, we're just writing an expression. So his money, his savings, or his future value is M. So I just write M. Okay? And what is his present value? Well, 1,500. Okie dokie. Excuse me, 15,000, right? And we're going to multiply that by, and we're just going to use the formula from the booklet. So we take our rate, which is 0.3%. We divide it by 100, but we also need to multiply that because I said it's going to compound monthly. We multiply that by 12 based on the formula. So that's going to be 1,200. And just to clarify, guys, that's this formula right here. Okay? See it right there? So we multiply by K, that's our compounding. 1,200. Da, da, da. And we don't know how many years. It says T years, but again, it's compounded monthly, so we do time times compounding, so it would be 12T. And honestly, for all intents and purposes, I guess you could just leave it like that, but we could do a little bit of calculating inside here if we wanted to. You know, you could take let's clear that out. You could take 0.3 and divide it by 1,200 to get, whoa, look at that. We know we have to shift it out of scientific notation, but we can do that. We know how to do that. So it's 1, 2, 3, 4. So you get 0.00025. And we could do that also and then rewrite that as a complete decimal if you want it inside, but we don't have to. We can just leave it like this, and that is A-OK with me. Let's keep it moving to question 3. All right, here we go. Question 3. One of my favorite questions on the financial math practice quiz. We have our friend Arlene. She's trying to buy a house. Good for you. So she's got 15,000. I think these are Australian dollars. But she needs 19,000 for the deposit. And she's going to try and save that up in 5 years' time. Okay, so she's got 5 years to make that become that. All right, good luck, Arlene. So she's comparing bank offers, and so all the banks she compares all compound quarterly. So we know that K would be, we can make a note there, that means K is going to be 4. That's a good thought process there. Okay. Actually, if we go back here, you know, if she has this, you can make these labels. Well, this is my present value, and this is what she wants, so that would be her future value. Okay. And so they say, well, what is the interest rate or the minimum interest rate that she needs to meet her goal. And they say, go ahead and give your answer to 3 sig figs. Okay, cool. Let's do this. So if we look at that formula, and again, I know I keep showing it to you guys, but it's okay. Here we go. It's this formula right here. We're just going to substitute in these pieces, right, and see what happens here. So future value is 19,000. Okay, and that's going to equal Arlene's present value of 15,000 multiplied by 1 plus, now we don't know the rate, so we're just going to write R, and it's going to divide by 100 times K, that's what the formula says, and we know K is 4, so that's going to be 400. And it's going to be raised to the power of 5 years multiplied by the compounding, so 5 times 4 is 20. Okay, this is a good initial setup. And now what we're going to do, before we start calculating this, we're actually going to run through this strictly algebraically, so we can show how to lay it all out, so that if you struggle with your calculator, you can still get a lot of credit by just being able to lay this out nicely. So we know I got to get to R. I can't get to R because it's on top of 400. I can't get to 400 because it's being added by 1. I can't get to added by 1 because it's in these brackets, and these brackets are all being raised to the 20th power, so that means this is the first place I can go. So 15,000 is multiplying by this whole thing here. The opposite of multiplying by 15 is dividing by 15. So I divide, 15,000. So I divide both sides by 15,000. Right? That has now canceled, and so I get to this stage. All right. Again, I want to get to R. I can't because this is happening and that's happening, so the next place I go is right out here. I got to handle this. So this means raised to the 20th power. The opposite operation of raising to the 20th power is taking the root 20. So we just take the root 20 of both sides. And if you take the root 20 of both sides, you get this whole thing right here. It's going to look like this. Okay. And now, all we have left is this, because that will cancel out. We're going to be left here. Okay. We're getting closer. So now I want to get to here, but I can't because I'm being divided by 400, and I can't get to the 400 because I still have to take care of this 1 plus. Well, what's the opposite of adding 1? Well, that's subtracting 1. Okay, so we'll do one more line down here. And then we'll move over to this space to solve it. Okay, so we got the root 20 of this information. And we subtracted 1. So now it just equals R divided by 400. Okay? Actually, I guess I can write it right here. And if you look at this, now we have R divided by 400. So what we do now is we just have to multiply both sides by 400, and then you have R all by itself. So I'm just going to put a big bracket around this whole thing so we don't get too confused. So if I multiply this side by 400, that's that. And if I multiply this side by 400, they would cancel. And so now you know that R would equal all of this information. So what we have to do now is, now look, this is good work, really, really good work. If I'm looking at this, I'm saying, wow, they really understand the process. Now the last part of the process is, can you calculate a correct answer, okay? So we just need to do all this math. Now this can get a little tricky, so I'm going to really try to show you this in the most basic way we can to make sure we totally understand it, okay? So I'm going to take 19,000, and I'm going to divide it by 15,000. Okay, that right there kind of gives me all of this information right here. So now I need to take the root 20 of this value. Okay. So I have the root 20 up here. I go here, now watch, I take this and I hit enter, boom, now I got the root 20 of that whole value. Boom, got all that. Next, I'm just going to subtract 1. And voila, that's good. Now I take all of that and I just multiply it by 400. And to be clear, this information here represents everything that happened inside of here. So now I just multiply this by 400. And there you go. This is going to be my interest rate. This is the minimum interest rate that our friend Arlene can accept. And if we want to, it says round to 3 sig figs, so we would just say R equals We have 4.75. That's our 1, 2, 3. But we have a 0.5 here, so this is going to round up. So it would be 4.76%. And there we go. That's that. Good job. Let's go to the next question. Question 4. Here we go. All right, here. Our friend Brian, he opened a new savings account. Cool. It's got an interest rate of 3.5%. It's compounded annually. That means K will be 1. All right, if we want to make some notes here, I guess we can do this. So we know R, we already got our R value. It's right there, it's 3.5%. We know K is 1 because it says compounded annually. His initial deposit, this is Great British Pounds, I believe, GBP, 3,000. So that's going to be his present value or his principal value, so that's 3,000. Okay. How much money will he have in 5 years? That means time is 5. Now this is just a straight up plug and chug or substitute in and do some good math. Again, we're just using this formula right here. So we're going to try to find his future value. And we know his present value. We know his rate. We know his K. And we know the N. So we're in business. I wrote T, but it's N, right? Time, but you'll get the point. Here we go. If we substitute in, we just say 3,000. Multiplied by 1 plus 3.5% divided by 100 multiplied by 1, but we're just going to leave it as 100 because 100 times 1 is 1. We all know that. And N is 5 because T is 5 time. There you go. We'll make that an N just to be better. There you go. N is 5. Okay. There you go. That's all we have to plug in. And we're in business. Okay. And you can just, let's get that right there. Okay. So we can do it like this, 3,000 multiplied by 1 plus, we put those in parentheses, so the calculator reads it correctly, it just moves it out of percentage. Okay, and then we close our parentheses and raise it to the 5th power, and there you go, we get 3,563.05, and it says round to the nearest GBP, where that's like the 1 value or the single one, so because it's 0, you got it. It's just 3,563 GBP. And there you go. Good job. Question 4 is in the books. Let's go do question number 5. All right, here we go. We're going to talk about some depreciation or something losing value, which unfortunately is also a fact of life, right? So we got this guy, Edward. He bought a car. Cost $35,000. Wow. Edward's doing okay for himself. And the car loses value every year, which is kind of true. So they say, well, how much would that car be worth after 5 years? And like Edward would do this maybe if he wants to sell his car in 5 years. Okay, so pretty straightforward question. This is your initial value or your present value. There you go. This is where we have to be careful. Your rate is not 17%, right? That's actually how much it's going down by. But if we multiply by that, we don't multiply our value by what it goes down by. We multiply by how much is left after it goes down by that much. So when you think of your, let's see how to say this. If you think about your initial formula, so when you look in the IB booklet, they're going to give you this formula. And it's pretty much the same formula, just you got to do a little bit of some kind of conceptual shifting, which is great. This is the skill we really want to work on. So this is the formula we get in the book, right? So, excuse me, the IB formula booklet. So when we look through this, if we substitute in and kind of think carefully, you'll see how it all happens. So the principal value is 35,000. Okay. But our rate, it's not going to be greater than 1. See, if you multiply by a number greater than 1, your value goes up. You have to multiply by a number less than 1 for a value to go down or to depreciate. So instead of plus, we say minus, right? And this is now, again, kind of the same idea, really. If you put a 17 up here for your 17%, and we divide it by 100, that's going to shift it out of percent, okay? And there's no compounding, so we just leave that as 1. There's no compounding, so it's the same as 1. And we raise it to the nth power, which is 5. In reality, what you're really going to get here is 35,000 multiplied by, now let's just do this real quick, okay? We just said 1 minus, let me so you can see it, sorry. 1 minus 17 divided by 100, and you're going to get 0.83. 17 over 100 is 0.83. So you're really just taking this value and multiplying it by 0.83 raised to the 5th power, right? And that's how you're going to find the value, right? So you're still using that same formula you're given, but instead of going up, you're subtracting, and then you'll be just fine, okay? And so here we go. Let's do that real fast. Let me see if I can. Sure, we'll do it over here. Okay, 35,000, multiplied by 0.83 raised to the 5th power. And that's it. That's all you're going to do. And you get 13,786. For this question, usually when we're dealing with money, we're always going to the nearest one value. So in this case, it's US dollars. So we would say 13,780, and so there's a 6 here, so this is actually going to go up to a 7. Now, how wild is that? After 5 years, look what his car's worth now. Wow, lost almost over half its value. Wow, wild thing to think about, but there you go. That's the right answer. Good job. All right, last question on the financial math practice quiz. It says, how much needs to be invested today at 6.5% annual interest rate, compounded monthly? Well, let's just write this information out. So we know R is 6.5%. Goody, goody. And we know compounded monthly, so then we know K is 12. Great. And then it says for the real value, that's a big clue here. They want the real value to be 100,000. And when they talk about real value, that's because we are going to be calculating inflation. But we'll get there in a second. Okay. So we want the real value to be 100,000. So we'll just call that RV, which is really just like your future value when you take inflation into account. Okay. There we go. In 10 years. So now we know that N is our time is 10. Okay, and then this is our inflation. And our inflation is at 4.2%. I'm going to take a second and not do that quite yet. We'll get there, okay? So first things first, we fill in our initial formula. And once again, you know, the initial formula is given to you right here in your formula booklet, and it tells you what everything means. Shada! Here we go. We're going to fill it in. We're going to say 100,000. Okay, equals, and it says how much? Well, we don't know this. This is like the PV. That's what we're trying to find. So I don't know. PV. And that multiplies by, and what the formula says, 1 plus 6.5 divided by 100 times K. Well, 12 times 100 is 1,200. Okay. And then it said raised to the 10th, 10 years. Well, 10 times 12, because it's N times K. 10 times 12 is 120. Okay, now this is where we got to get a little careful here. When we take this growth, we have to compensate for inflation. So this is actually going to get divided by inflation. Inflation, you just take 1 plus you take the rate divided by 100. And so this is directly from the previous formula, right? It's the same idea. But there's no compounding, and it is just the same time. And there you go. That's it. This is, we can do this this might help you guys a little bit. This is our initial setup. So this is how much our money grows. This is how much our money gets compensated for inflation, and that will tell us our real value. Now, conceptually, if we wanted to just isolate PV, the present value, so it's taking this multiplied by this whole thing. Conceptually, if this is multiplied by all of this, I could just divide that from both sides and I'd have my present value isolated. So I'm going to show that real fast. Right? So if I took my 100,000 and I divided it by all of this, that would move it over there. This is what you would get. 1 plus, and I am just copying this real fast. And the reason I like doing this for you guys is, again, I want you to realize that if you struggle with the calculator, and I understand, it's another thing to learn, you can at least really show me that you understand the process and that you're just struggling with the calculation on the calculator. Because right there, 100,000 divided by all this will give you the number you need. So now let's do that. Let's talk about how to tackle all this information. And I'm going to break this one into pieces for you guys. You tend to do better when we do that. Okay. So here we go. Okay. First things first. We do 6.5 divided by 1200. Okay, that's that value. We add 1. There we go, and we raise it to the 120. Okay, great. That's that value right there. We're going to take, now we're going to do this value, then we're going to talk about how to pull values down and divide them, okay? So we'll do this one. This one I'll do a little bit cleaner. I'll say 1 plus 4.2 divided by 100. Okay, I'm going to raise that to the 10th power. Okay, so this 1.912, all that, that's the top. That's the numerator. This is 1.5089. That is the denominator. So all I have to do is go up here, take this, divide it by that, right, and hit enter. And now this whole value right here is everything you see in those brackets, right? So now all I have to do is take 100,000, that's that right there, and just divide it by that value. And there you go. We're going to get 78,900 and we don't want to say 12, we're actually going to say 13 because we're going to round up, right? There you go. And I think it's euros, yeah, euros. So there you go, 78,913 euros. That's what our value would need to be if we wanted to grow in 10 years to be 100,000 euros, okay? And that is the real value after compensating for inflation. All right, and that is your practice quiz for the financial math section of your quiz. Just so you know, when I go over the logarithm and exponents portion of this practice quiz, after that, I will take a minute and go through all of the communication stuff. So go to the next quiz. If you want to hear all the communication topics at the end, I will do those at the end of the logarithm and exponents practice quiz. All right, guys. Thank you. Bye.